Hello, my dear students. Welcome you all to Sri Jaindra Rank Zone classes. I'm your mentor and your friend for the subject chemistry, and I will be taking the organic chemistry. My dear students, as you all know that we have started the qualitative analysis of organic compounds in the last term. We have already started the quantitative estimation of organic compounds in which we discuss about how to calculate the percentage of carbon and hydrogen respectively. Today I am going to start with estimation of nitrogen in organic compound. In organic compound. So we have to actually learn two methods. There are two basic methods. First is the Duma method, that is Dumas method, Dumas method, and the next is the Zeldol's method. Okay, so these two are different techniques for the estimation of nitrogen, the Dumas method and the Zeldol's or Kizal's method. Okay. Now, first we are going to discuss about the Dumas method. Okay. According to Dumas method, a known weight of organic compound is heated. Weight amount of the compound is heated with cupric oxide CuO in the atmosphere, in an atmosphere of carbon dioxide CO2. Okay, so we have to heat the sample, the organic compound sample. Okay, which is heated with the CuO. Okay, in an atmosphere of CO2, right? Under these conditions, under these conditions, carbon and hydrogen present in the compound carbon and hydrogen present in the compound are relatively are oxidized respectively to CO2 and water. Okay, they left behind the N2 gas, the nitrogen, which set free after the release of CO2 and water. Now some oxides of nitrogen may also be formed. Also be formed, but they are reduced by passing them over red hot copper spiral. in spiral tube, red hot copper spiral. Okay. Okay. So the reaction, the carbon, it will combine with CuO to form CO2 gas. Hydrogen to form water. Nitrogen to form nitrogen oxides. N2 plus small amount of nitrogen oxides. Okay. These oxides of nitrogen, they combines with copper to form I mean the nitrogen gas released is released. Okay. So the oxides of nitrogen, when heated, when reduced within the presence of copper, okay, when they are passed over the copper spiral tube, okay, they will form only the nitrogen gas, whereas the oxide component will be, taken up by the copper part to form C. Understood? Now, the nitrogen set free is collected over the nitrogen is collected over Schiff's nitrometer over a Schiff's nitrometer, which contains concentrated KOH. Okay, concentrated KOH absorbs all other gases except nitrogen. Okay, they absorb all other gases except nitrogen. The volume of nitrogen collected is noted after leveling. Is noted after leveling. Okay. Room temperature and atmospheric pressure are also recorded. They are also recorded. Okay. From this, the percentage of nitrogen can be calculated. How? Percentage of nitrogen is, the formula comes to be 28 upon 22400 into volume of N2 gas at STP upon weight of the compound into 100. Okay, I will derive the formula for you, how this formula actually came into existence. This is the formula to calculate the percentage of nitrogen in the given organic compound. Okay. The biggest merit of this method is this method can be used to estimate nitrogen in all types of organic compounds. It can be used in it can be used to calculate the percentage of nitrogen in all types of organic compounds. Now, how this formula we reach to this formula? See, suppose the given weight of organic compound is W grams. This is the weight of organic compound. When the given weight of the organic compound is, suppose it is W grams. Okay. Now, at experimental conditions, the nitrogen gas formed okay during experiment we conduct an experiment. Okay, I have already explained the experiment, that how the organic compound combines with CuO to form a relative of its oxides. Okay, some of the oxides of nitrogen will also be prepared, but we will reduce. Okay, the oxides of nitrogen will be reduced to form the nitrogen gas. Okay, now the fact is that when this nitrogen gas is formed at experimental condition, the pressure and the temperature of that condition is to be noted down. That is why it is given that the pressure and the temperature of the condition to be noted down. Okay. So at experimental condition, the volume of nitrogen collected is V1 ml. This is the volume of the nitrogen collected. Okay, at experimental condition V1 ml. Okay. The room temperature recorded at the time of formation of nitrogen during experimental condition. So the room temperature recorded is T1 Kelvin. Okay. So the volume of nitrogen, the volume of nitrogen collected is V1 ml. The room temperature is T1 Kelvin. During the experimental condition. Okay. There are two conditions. One is the standard temperature and pressure, and the other one is experimental condition. Understood? Okay. Now, so the volume of nitrogen at STP, you know the volume of nitrogen at STP, okay? You know the volume of nitrogen at STP for 1 mole is 22400 ml for 1 mole, okay? But you don't know that how much or how much amount or what is the number of moles of nitrogen gas which is going to be formed. What you have to do, you have to basically compare two conditions, the experimental condition and the standard temperature and pressure conditions. As you know, the volume of the nitrogen collected is V1 ml. Okay. The room temperature is T1 Kelvin. The pressure during the pressure, see the pressure which is at experimental condition, pressure at experimental condition is T1. Okay, it is P1. Now, this P1 will equivalent to atmospheric pressure minus aqueous tension. What is aqueous tension? Aqueous tension is, I should say in simpler words, in simpler means, aqueous tension is the pressure exerted by the water vapors at standard temperature and pressure. Okay, so at room temperature, the amount of pressure exerted by water vapors is aqueous tension. As you know, the gas is formed with the downward displacement of water, and because of heat, some of the water also come into vapor phase. So you will be having you will be having the pressure from the gas and the pressure from the water vapor. So to get the pressure of the dry nitrogen gas, so P1 is the pressure of dry nitrogen gas. Pressure of dry nitrogen gas. Okay, which is equivalent to atmospheric pressure minus aqueous tension. Now, at the condition of standard temperature and pressure at STP, the pressure P2 is 716 newtons of mercury. The volume V2, you don't know the number of moles, so you have to calculate. And temperature T2, 273 Kelvin. Now, at experimental condition, P1 is P1, you have to calculate, okay? Volume is V1, temperature is T1, okay? So now, according to the gas equation, P1 V1 upon T1 is equal to P2 V2 upon T2. So you know V1 is equal to P2 is 760. Sorry, you have to calculate V2. V2 is equal to P1 V1 into T2 upon P2 into T1. So P1 you have you have been given, P1 you have been given. Now T2 is 273. P2 is 760 into T1 you will be given. Okay, so V2 you have to find out in from this. So V2 is what we have done. We have basically calculated the amount of volume of the nitrogen gas. Okay, and we came to know that amount of nitrogen gas which is formed at experimental condition is how many times equivalent of the volume of the nitrogen found at STP for one. Okay, so V2 can be easily calculated. Now you know that the nitrogen gas which is formed at STP, if we take 1 mole, so 22400 ml of nitrogen gas weighs what? 28 grams. The amount of weight and the amount of volume. The amount of volume is 22.4 liters, that is 22,400 ml. And the weight of this much amount of gas, this much volume of gas acquires a weight of 28 grams, right? Now, for 1 ml, the weight will be, for V2 ml, you will calculate the V2. For V2 ml, 28 upon 22400 into V2, okay, into 100 upon weight of organic compound. This is the formula. That is, percentage of nitrogen is equivalent to 28 upon 22400 into volume of the nitrogen gas evolved into 100 upon weight of organic compound small w. This is the formula. Understood? Yes. This is one of the method, Dumas method. Okay. Now, a general reaction you have to remember, like this is the compound This equation will help you to balance it. XCO2 plus Y by 2 H2O plus Z by 2 N2 plus Y by 2 of C. This is the equation. Please remember, if in case you got stuck during balancing of the chemical reaction. Okay. So this is the Dumas method. Now we will solve one question. Okay. One problem we will do. In Dumas method for estimation of nitrogen, for estimation of nitrogen, 0.3 grams of an organic compound gave 50 ml of nitrogen collected at 300 Kelvin temperature and 715 mm of Hg pressure. Calculate the percentage of nitrogen. Okay. Given aqueous tension at 300 Kelvin is 15 millimeters of Hg. Now, the formula is percentage of nitrogen is equivalent to 28 upon 22400 into volume of nitrogen evolved into 100 upon weight of organic compound. This is the formula. Now, in this, they have already mentioned that 0.3 gram is the W. If 50 ml of nitrogen collected at 300 Kelvin and 750 mm of pressure. Okay. Now, this volume is the experimental volume, but this volume is the volume of the nitrogen at STP. Okay. Now, what do you have to do? P1 V1 upon T1 is equal to P2 V2 upon T2. Same formula, we have to find out the volume of nitrogen at STP, that is V2. Okay. Now P1 is given 715 minus 15, that is 700. Okay. V1 is given 50. T2 is given 273 upon P2 is given 760. T1 is given 300. So it comes around 41.9 ml after solving. This is the volume of the nitrogen gas at STP. Okay. Okay. Now, 12,400 ml occupies 28 grams. 41.9 ml occupies weight of organic compound zero point 0.3 into 100. So the percentage comes to be 17.46%. This is the percentage of nitrogen. This is the way we calculate it. Now the next method is most important, very important. Okay, although I may be wrong in pronouncing it, okay, but for me I can say it is Zellol's method or Kizal's method. Okay. So this method, the nitrogen is estimated in the form of ammonia, and in Dumas method, the nitrogen is estimated in the form of nitrogen gas. Please remember it. Okay. So the compound containing nitrogen is heated with estimated form is ammonia. Now, the compound containing nitrogen is heated with concentrated sulfuric acid. Is heated with concentrated sulfuric acid. Okay. The nitrogen present in the compound, when heated with concentrated sulfuric acid, gets converted to form salt because nitrogen and the compounds of nitrogen are basic in nature. Okay. Form salt, ammonium sulfate. Okay. Now we have converted the compound which is containing nitrogen, okay, to form ammonium sulfate. Okay. When nitrogen, the another nitrogenous compound is heated with concentrated H2SO4, okay, we use some of traces of potassium sulfate K2SO4, which raises the boiling point of H2SO4. K2SO4 is added to raise the boiling point of H2SO4, and CuSO4 act as catalyst. Okay, so carbon plus hydrogen plus nitrogen, they are the components from organic compounds, and when heated, it forms ammonium sulfate. Okay, the liberation of CO2 and water. The resulting solution is then distilled with excess of sodium hydroxide. With sodium hydroxide, so ammonium sulfate, it reacts with sodium hydroxide to form sodium sulfate with liberation of ammonia. Okay, next, ammonia thus evolved is absorbed in a known but excess volume of standard HCl or H2SO4. Ammonia thus evolved is absorbed in a known but excess volume of standard HCl or H2SO4. Okay. Now, some of the part or the volume of the acid is neutralized by this ammonia, and some of the unreacted acid, the acid which is left, is estimated by titration against standard NaOH against standard sodium hydroxide solution. Okay. From this, the amount of acid used against ammonia is found. Okay. So basically, what we have done, we have taken known amount of acid, but with excess volume. In the molarity or the normality of acid, it should be same as that of the base we are going to take. Okay. So the fact is that we have to take excess volume of standard acid because it is having dual function. One function is to neutralize NaOH, okay, and the one function is to neutralize ammonia. Understood? So there are two functions. Okay. The resulting acid mixture is then heated with sodium hydroxide, and before it, we have already taken it for the evolution of ammonia gas. So organic compound plus H2SO4 forms ammonium sulfate, which when reacted with NaOH forms Na2SO4 with the liberation of ammonia. Ammonia being basic, again it reacts with H2SO4 to form ammonium sulfate again. Okay, that is why the ammonia, it will try to titrate H2SO4, but as H2SO4 normality is different from ammonia, okay, it will not be completely used up. Okay, so the leftover part will be used to utilize NaOH. Now suppose the mass of organic compound is W grams. Volume of H2SO4 of molarity capital M, okay, is V1 VmL. So we have taken the molarity of H2SO4 capital M. The volume is VmL capital V. Volume of NaOH of same equimolar, mean molarity will remain same. Then only number of gram equivalents or the number of titrating equivalents will be same. So volume of NaOH or molarity capital M used for the titration of excess of amino acid, used for titration of excess or leftover unreacted H2SO4 is V1ml. Now, as you know, the N factor of NaOH is 1 and the N factor of H2SO4 is 2. So basically, NaOH is not going to completely neutralize H2SO4. So H2SO4, if we want to completely neutralize H2SO4 by NaOH only, then we have to take double amount of NaOH, or we can say the ammonia which is formed is double the amount of H2SO4 taken. So the V1 ml of NaOH of molarity M, okay, it will be equal to only half of the volume will be used, okay, for the neutralization of H2SO4. So the volume of the H2SO4 used to titrate NaOH is V1 by 2 ml of H2SO4 of molarity capital M. Now, the unreacted acid will be the volume of the unreacted acid, unused acid will be V minus V1 by 2 ml. Okay. This unreacted amount gives the double amount of ammonia. So the amount of ammonia will be, because the reaction is just in front of us, 2 moles of ammonia we are getting from 1 mole equivalents of H2SO4. So volume of ammonia evolved is 2V minus V1 by 2. Understood? Now, if we take a liter solution, meaning 1000 ml of 1 m ammonia, it gives 17 grams of nitrogen, NH3, 17 grams of nitrogen. This 17 grams of ammonia, 17 grams of ammonia gives 14 grams of nitrogen. So in the formula, 14 plus 3, 17 grams of 1 mole of ammonia gives 14 grams of 1 mole of nitrogen. Okay. Now, the volume of ammonia solution of molarity capital M contains how many grams of nitrogen we have to find out. So if we take 1000 ml, we get 17 grams of ammonia, which gives 14 gram of nitrogen. So ultimately 1000 ml of NH3 gives 14 gram of nitrogen. So 1 ml will gives 14 upon 1000. Now this amount of ammonia gas is evolved. So into 2 V minus V1 by 2 into 100 upon weight of organic compound. Okay, we have to multiply the molarity as well, because the molarity, if we are taking H2SO4 and NaOH, then it's okay. We are taking some monoprotic acid, then it will get changed. Okay, understood? So this is the formula. So percentage of nitrogen formula comes to be 14 into M into 2 V minus V1 by 2. This is the amount of ammonia gas evolved, or the amount of acid which is unused, which remains unused, into 100 upon 1000 into weight of organic compound, that is small w. Okay, so this is Zeldol's method. In the next in the next class, I will discuss one problem related to Zeldol's method, and we will start the Carius method, detection for halogens, and the other methods left over. Till then, bye bye, take care, stay safe, stay healthy.